Hello students, welcome to Swapna Physics classes. In this lecture, I am going to teach you one more important question for your TS first year IPE examination. And the question is, how is the average velocity different from instantaneous velocity? Average velocity is nothing but the change in the position or displacement which is denoted with delta x. The change is denoted with delta and the position or the displacement is denoted with x. Okay, in the time interval delta t in which the displacement occurs. For example, a car is moving on a road. Okay, at time t1 it is at a point O and it is displaced to a distance of 5 kilometers at time t2. Or else I am taking the position at t1 is x1 and at t2 it is x2. Now the average velocity, okay, v bar denotes the average quantity, okay, which is equals to change in displacement to the change in time, or the change in displacement in a time interval delta t, which is equal to x2 minus x1 by t2 minus t1. x2 minus x1 by t2 minus t1 is the average velocity. And if you want to represent it graphically, I am taking the time along x-axis and displacement in meters along y-axis. I am taking time in seconds. Okay, this is the origin and the time is 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, and so on. I am taking 5 meters, 10 meters, 15 meters, so on. And if this is the motion of a car, and in 2 seconds, if this is the position of the car, and in 3 seconds if this is the position of your car. Okay, and what is the displacement, what is the average velocity we have? V bar is equal to x2 minus x1. This is x2, this is x1, 20 minus 10 by t2 minus t1. t2 is 3 and t1 is 2 seconds, which is equal to 10 by 1 meters per second. This is the way to find out the average velocity. Okay, and coming to the instantaneous velocity. What is instantaneous velocity? The velocity which occurs at a particular instant of time. The velocity which occurs at an instant time. Okay, see, when a car is moving on a road, okay, initially the time t1 is equal to 0, the time t2 is equal to some 2 hours I am taking, for example. Okay, and I just want to know at this instant of time what is the velocity of the car. At this instant of time I am taking it as t. Okay, after traveling for 1 hour, what is the velocity of the car? I have to find out. Okay, this velocity is known as instantaneous velocity. Okay, and graphically it is represented as displacement in meters along y-axis and time in seconds along x-axis. I am taking it. And if this is the motion of the car at 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and 5 meters, 10 meters, 15 meters, 20 meters, and so on. Okay, at particular time, that is at 3 seconds, what is the velocity of the car? Let's see. At 3 seconds it is about 10.2 by 3 seconds. At particular instant of time, that is at 3 seconds, the position of the car is 10.2 meters and the velocity is 10.2 by 3 seconds. Okay, if you just divide this, what is the answer? You just find out it. I had given for example. Okay, so the difference is in interval of time, what is the velocity of the object? What is the velocity of the object is known as average velocity. If you subtract the final position of the car, okay, minus initial position of the car divided by final time minus initial time, you will be able to find out the average velocity. And for instantaneous velocity, at a particular instant of time, what is the velocity of the car or some object? This is the only difference. And both these are vector quantities. Why? Because the displacement is a vector quantity. The displacement or the position is a vector quantity. Therefore, the average velocity and the instantaneous velocity are also vectors. Okay, and I will end this lecture here itself. If anybody didn't subscribe to my channel, please subscribe to my channel and click on the like button, and please share with as many people as possible. Okay, bye.